I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is clear so that we can proceed for the session. Till you are going to report me this, let me just brief you what is the ideal duration and what is the agenda for today's session, friends. The ideal duration for today's session is going to be approximately 45 minutes. And the agenda or the outcome of the session is that in today's session, we are going to discuss some of the important questions related to your topic, synchronous machines for GATE 2023. Right now, we are having this session under the GATE Champion series, which is completely free of cost. And you can prepare well with this series for your upcoming GATE 2023 examination. We'll be discussing some important concepts also with the help of the questions. So stay tuned to me for next 45 minutes and we'll be discussing some basic parts, some basic concepts of synchronous machines in this session. And then we are having another session, that is part 2, that will be planned on Monday. So Monday we'll be having little more advanced problems and some more concepts related to synchronous machines. So all the candidates who are joining me live, just quickly confirm your presence and tell me, are you there? And do not forget to like, share and subscribe the session. If you like the session, press the like button, share it with your friends and colleagues, and do not forget to subscribe to BYJU'S Exam Prep for all important updates and notifications. So let us start with the session. But before that, some of you may be joining me for the first time. So there is a brief introduction about myself. My name is Ashutosh. As you can see on the screen, I have 11 plus years of teaching experience, completed MTech from BYJU in 2010. I have written a couple of books. And these are my areas of expertise, that is power system, electrical machines, electromagnetic field theory, material science, engineering ethics, and current affairs. Before we start the session, we have one very important series for all of you. If you want to ace GATE 2023 with free GATE Achiever series, then you can register yourself. You have to go to the BYJU'S Exam Prep app. You have to get yourself registered and you can access this GATE Achiever series, which is available on the BYJU'S Exam Prep app. If this app is going to be available on Google Play Store, if you have not downloaded, please download it. Mr. Jaunpur is saying, sir, machine ka pura cover ho jayega. See, you have to see things in the parts. You have to see things in the parts when it comes to YouTube. We have already covered almost every subject in different sessions. You can also follow the playlists that are mentioned in the channel. You can follow the playlist, all the subjects, every topic, every concept, and various questions are covered in that. So you follow this GATE Champion series. Along with that, there are some previous series which also you can follow. So overall, you can say all your machines or whatever subject you are targeting, that is going to be completed in almost complete respect. And still, if you have any doubt, then you can join my personal Telegram channel on BYJU'S Exam Prep, that is Electrical by Ashutosh. That is my name, Ashutosh Saxena. And still, if you have any doubt, just join this Telegram channel and you can ask number of your doubts, daily doubts you can ask me. I will be more than happy to take up your doubts. Is it clear, everybody? So you can join this series on the app, BYJU'S Exam Prep app, if you want to ace GATE 2023 free of cost. Now we have another important session, a workshop which is conducted on 27th of September. The timing is 8 p.m. How to ace GATE with college or job. If you are a working professional, if you are already in your BTech, then how you should project your preparation. This session is going to be very important, and this session is conducted by one of the most reputed faculty for instrumentation, that is Faneen Sir. He is having more than 11 years of experience. So if you want to attend this session, this workshop will be conducted on the BYJU'S Exam Prep app. You have to log into BYJU'S Exam Prep app, follow the simple notifications, and you can register yourself for the workshop. Log the calendar, 27th of September, 8 p.m. in the evening. Now, before we start discussing synchronous machines, let me just give you some brief idea about this particular machine, because then you are going to be in synchronization with what we are going to discuss. So let me just brief you. If you talk about synchronous machines, let us first talk about synchronous generators. Like any other machine, synchronous generators are also going to have two important parts. The first one is stator, that is the stationary part, and then we have rotor, which is the rotating part, Now, if you ask me, and if you compare the induction motor and synchronous machine, then I will tell you that the stator of an induction motor is going to be quite similar with the stator of an synchronous machine, or you can say synchronous alternator. The stator is also going to have distributed windings. We have discussed it in the previous class. It will be having distributed three-phase windings which are 120-degree displaced in the space. Kamraj, see, listen. When you are coming for a paid course, please try to understand, in paid course, there are some bound commitments. Okay, there is some regularity, there is some step-by-step classes are there, a study plan is complete, a study plan is there. And apart from the classes, GATE preparation is not just about attending the live classes. Actually, the real work starts after attending the live class. Thousands and thousands of people are going to be joining the live sessions, maybe on YouTube or other platforms. But after that session, the real work, the real hard work starts. And it is BYJU'S Exam Prep which helps you in that particular zone. We have daily quizzes, we have mock tests, we have subject-wise tests, we have weekly tests, full-length tests. So many other things are happening in the background. So that will be available when you come for a paid course, because a lot of people are involved in that hard work and a lot of team structure, infrastructure is required. So when you are coming for YouTube, YouTube is, you can say, is a prerogative of the faculty. The faculty who is taking the sessions. For example, if I am taking machines now, so I have started with induction motor. Now I am dealing with synchronous machines. So I have some time limitations. I cannot go without any time limitation. There are some time limitations. So I have to abide by that time limitation. But when you are coming for a paid course, it has some bound commitment. So that is the benefit of coming into the paid course. Is it clear? See, in terms of syllabus coverage, obviously syllabus coverage is going to be much better when you come for a paid course. Yes. In YouTube, nobody can provide 100% of the syllabus. If somebody is saying this, it is a complete lie. And at your age, the most important problem is that anybody can fool you very easily. Okay, nobody can give you 100% complete syllabus on YouTube, because there are limitations. But when you are coming for a paid course, 600 plus hours of paid course, when you come for the vision, 600, 700 hours of paid course, then you can enjoy what is proper preparation, what is proper planning, exact planning required. Anyways, so let us come back to the topic. Synchronous generators. We have a stator, which is a stationary part. It is very similar to the stator of an induction motor, having a distributed three-phase winding which are 120-degree displaced. Now coming to the rotor, we have basically two types of rotors. One is cylindrical rotor, and the other one is salient pole rotor. Salient pole rotor. I will just give you a brief idea what is this cylindrical rotor and salient pole rotor. Later on, if you want some more stuff, more theory, more theoretical background you want, then you can join you join my personal Telegram channel, okay, on BYJU'S Exam Prep. I will give you the link of the playlist where complete electrical machines I have covered. The theory portion, complete electrical machines I have covered. I will send you the playlist if you want the complete theoretical background. So you can join my personal Telegram channel. I have already mentioned in the starting of the session, that is Electrical by Ashutosh Saxena. I will be sending you the link. You can follow those lectures if you want the complete coverage of the theoretical background. Good evening everybody. Shashi, Payash, how are you? Welcome to the session. Now if you see, I will just give you some brief idea. If you talk about the cylindrical rotor, The cylindrical rotor is going to be something like this. Something like this. So it is going to be cylindrical in structure, and there will be slots and tooth. This is what we call as slot and tooth. This is going to be tooth, and this grooved area is called as slot. The windings are going to be placed. The windings are going to be placed. The windings are going to be placed in the slot area. Windings are going to be placed in the slot area. Are you getting this? So by using different number of conductors in various slots, we are getting poles generated in case of a cylindrical rotor. When it comes to, this is a cylindrical rotor. This is a cylindrical rotor. And if you talk about a salient pole rotor, then it looks something like this. There may be more number of poles for salient pole, but just for the sake of clarity, I am just giving you 4 number of poles. So you see, this is called as salient pole rotor. And you see these poles are projected. They are having saliency. That is what they are called as salient, because they are having saliency. That is why they are called as salient pole rotor. If you talk about the speed, the synchronous speed, how you are defining it is 120 F upon P. So if you see the cylindrical rotor, generally cylindrical rotor, number of poles are 2 or 4, not more than 4. Because of the constructional limitations, you can understand the cylindrical rotor is generally having very less number of poles, maybe 2 or 4, not more than 4 generally. So you see, for a cylindrical rotor, the number of poles are very less. If the number of poles are very less, the synchronous speed is going to be very, very high. It means cylindrical rotor synchronous speed is very high, and that is why these are used with steam turbine, and they are called as turbo alternators, because they operate at very high speed. When it comes to the salient pole rotor, they have very high number of poles, maybe 6, 8, 10, 12, and maybe more, you can say. So if number of poles are going to be high, suppose it is 120 F upon P, number of poles are high, then synchronous speed is going to be less. So these rotors, salient rotors, they are having number of poles high, hence synchronous speed is less. So basically they are inducted in the hydropower plants, and that is why they are also called as hydro alternators. Is it clear, everybody? Just tell me yes or no in the comment section. Are you able to follow this? Good evening, everybody. Vishnu. This much is clear. This basic idea is clear about the cylindrical and salient pole rotor. You must be having this idea. Now you see, if you talk about the synchronous machine, suppose you talk about DC machines. DC machines, we have no choice. The armature winding has to be on the rotor side. If you talk about DC machines, armature winding has to be on the rotor side. and field winding is going to be on the stator side. This is fixed. Why it is so? Why it is so for DC machines? Because the commutation is possible only with the rotating armature. Commutation is possible only with the rotating armature. Thank you. Commutation is possible only with the rotating armature. Rotating armature. If you talk about the induction motor, induction motor stator windings, they are connected with the three-phase supply. In general, I am saying stator windings are going to be connected with the incoming three-phase balance supply, and the rotor may be a squirrel cage rotor or slip ring or wound rotor having the windings. Are you getting that? So this is also fixed. It may be a cage rotor, or it can be a slip ring, or it can be wound rotor. It is fixed. But when it comes to the synchronous machines, two types of constructions are possible. First one is you can have stator, you can have field windings. And rotor, you can have armature windings. Second case is also possible. Stator, you can have armature winding, and rotor, you can have field windings. Is it clear, everybody? Now, generally this construction, when stator is going to have the field winding and rotor is going to have the armature winding, this will be preferred when it is a small size machine, when the rating is less than 5 kilowatt. When the rating is less than, approximately I am saying 5 kilowatt, then generally we go for this type of construction. But when the rating is high, when the machine size is very large, generally if you talk about the synchronous generator size is going to be very large, because we are not generating power at a small scale, we are generating power at a very high scale. That is going to be mega volt amperes, yes or no? So at such a high rating, we go for the second construction, large size, when the rating is in MVA, mega volt ampere. Are you getting this? Now, what is the reason why we go for this construction? Generally, let us understand. If you talk about synchronous generators, the synchronous generators, armature winding is going to carry huge amount of current. The size of the armature winding is going to be very bulky. Now you understand, to handle the high currents, if you have a bulky armature, big size armature, and you make the armature winding rotating, then what will happen? The amount of rotational losses will be very high. The amount of rotational losses will be very high, and it will be practically quite complex to have a rotating armature of this much bulky size. At the same time, because of the high current, the temperature of the armature winding will be very high. So we want effective cooling. Now for such a big size rotating armature, you cannot provide effective cooling. That is also a big problem. To avoid all these, you can say, problems, we put the armature winding in the stator, that is the stationary part, and we make the field winding rotating. If you talk about the field winding, the field winding is going to have DC excitation, DC excitation. Okay. And now let us come to the basic concepts of rotating machine. For any rotating machine, I have told you some simple principles to be followed if you want a stable rotating machine. One of that concept is that there should be no relative motion between the two fluxes or the two magnetic fields. Yes or no? Now you please understand, the stator of your synchronous generator is going to be similar to your stator of the induction motor. And it is going to have a rotating magnetic field. That rotating magnetic field is going to be rotating at the synchronous speed. And you are providing the field winding to the rotor, and that is a DC field winding. So definitely the rotor is going to be rotating at the synchronous speed. Yes or no? Are you able to follow this? The rotor must be rotating at the synchronous speed, because then only there will be no relative motion between the two fields or the fluxes, and then you will be having a stable rotating machine. Is it clear, everybody? So this was some background related to synchronous machines. I hope you get the point. If you want some more elaboration, you want more theoretical details, and you want a complete coverage, then I have already suggested join my personal Telegram channel on BYJU'S Exam Prep, that is Electrical by Ashutosh Saxena. I will share the link. A complete list of videos for electrical machines, they are available on the same channel playlist. I will send you the link, you can follow that. Anyways, so let us start with the first question. In today's session, we are going to have comparatively simple questions we are having. In the second part, we will be having little more advanced type of questions. Let us see what this question is saying. This question is saying a three-phase 16 poles alternator has 144 slots, and he is asking what is the distribution factor. How we define the distribution factor? You must be aware that if you are talking about the EMF per phase RMS value of a synchronous generator, my friend, class is available every day 6 p.m. in the evening. Class is available. Okay, I have started machines just 2 days back, so you can follow machines. For other subjects, you have to follow the previous sessions, and after machines you can follow other subjects also, but the timing is going to be same, 6 p.m. in the evening on the same channel, that is BYJU'S Exam Prep English channel. Now you see it is having 4.44 F pi, and suppose this is number of turns per phase. Okay, and then we have one factor which we are calling as winding factor. This winding factor takes into account the pitch factor and the distribution factor. The pitch factor and the distribution factor. Why we are introducing these factors? In simple words, you can understand that because of certain harmonics, we go for different types of windings. For example, we are going for fractional slot windings. For example, we are going for short pitched windings. We are not going for full pitched windings. We are going for short pitched windings to avoid the harmonics, to avoid certain harmonics. But on one hand, when you try to ignore or avoid those harmonics, on the other hand, the value of EMF that you are getting as the output of the generator, that is also little bit compromised. So that compromised EMF is being represented by this winding factor. This winding factor is a product of pitch factor and the distribution factor. Pitch factor, and this is distribution factor. How we are defining the distribution factor? How we are defining the distribution factor? You must be knowing the formula. The distribution factor we are defining as sine m beta by 2 upon m sine beta by 2, where m is defined as number of slots per pole, number of slots per pole per phase. And beta is defined as the slot angle. Beta is defined as the slot angle. What is the meaning of slot angle? Let us try to understand. Suppose this is your stator. Okay, this is your stator. Just try to understand the emotions. I am not a great artist. Okay. But I think you can understand it. Okay, something like this. So this is going to be your stator of the synchronous machine or synchronous generator, where slots are going to be provided, where windings can be placed. When I say slot angle, you please understand, it is the angle subtended by the adjacent slot. This angle we are defining as beta. This angle we are defining as beta. Is it clear, everybody? Now, if you see how we are defining this angle beta we are defining as 180 degree electrical, number of slots per pole, Now, how we are defining this beta, let us try to understand. You are defining beta as the slot angle, that is the angle protruded by one slot. What is the total angle, physical angle, can you say? Yes. 180 degree electrical multiplied by the number of poles. This is going to be the total 360 degree angle. Yes or no? Because 180 degree electrical is the physical angle between the two adjacent poles. So if there are p number of poles, the total 360 degree angle, total circumference you will be representing by 180 degree electrical into number of poles. Divide this total 360 degree by number of slots. So that will be your beta. This is how you can understand this slot angle. Is it clear, everybody? Now, let us try to find the values of m and beta. Just put it there and you will get your answer. What is number of slots per pole per phase? Number of slots are 144. Number of poles are mentioned as 16 and 3 phases. Just tell me what is the values you are getting. This is 180 degree electrical, number of slots divided by number of poles. So this is going to be 16. Just solve this and tell me what you are getting. If you put the values as per my reference, you must be getting 0.96 as the distribution factor. Sine m beta by 2 divided by m sine beta by 2. Put the values, you will be getting 0.96. Everybody is getting that? Yes, Murli, are you getting that, everybody? So generally we define the rating in volt amperes. Okay, generally we define the rating in volt amperes. Anyways, let us go to the next question. What is the distribution factor for a uniformly distributed 3-phase winding having a phase spread of 60 degree? Let us first understand what is this phase spread. Phase spread is defined as m into beta. Now you will ask me, sir, how? How you are saying this is phase spread? It is represented by sigma. Now you tell me what is this m? M is number of slots per pole per phase. It is number of slots per pole per phase. For one phase, for one pole, how much slots are there? Yes or no? If you multiply that number by the slot angle, then you will get the phase spread. Yes or no? Then you will get the angular displacement for one phase. Yes or no? So that is how we are defining this. Beta is slot angle. Anyways, let us first understand now what is uniformly distributed winding. What is uniformly distributed winding? I have just shown you that your stator is going to be something like this. Slots are going to be there. Suppose it is a cylindrical, rotor, something like this. If you see the air gap, between the tooth and the rotor periphery and the slot and the rotor periphery, there is a sudden change. Every time there is a tooth, every time there is a slot, there is a sudden change. Because of this sudden change in the air gap, definitely, if you see the output, in terms of slot or tooth harmonics, then we want a sinusoidal output, but actually what we are getting is something like this. Because of slot or tooth harmonics. We want to avoid these slots or tooth harmonics. So what we are going to do? One way of removing this discrepancy is to reduce the slot angle. Yes or no? How much you can reduce the slot angle? Theoretically, you can reduce it to 0 degree. If you increase the number of slots to infinite, then what will happen? Theoretically, I am saying the slot angle will be almost 0. So there will be hardly any difference or abrupt change in the air gap for slot and tooth. This ideal picture we are using practically to minimize the slot or tooth harmonics. What we are doing, we are assuming that number of slots, they are very high. If number of slots are very high, slot angle is going to be very small. I am saying almost 0 degree, very close to 0 degree. If this is the condition, so can I say sine beta is, or you can say not beta, you can say simply beta by 2. Actually, beta by 2 is simply going to be beta by 2. So if you put it here, your distribution factor will become sine m beta by 2 upon m. Now sine beta by 2 will be m beta by 2. But I have just told you that this m beta is nothing but the phase spread. So for a uniformly distributed winding, the distribution factor can be written as sine sigma by 2 upon sigma by 2. Now you just put the values, you will get the answer. But one thing you have to remember, whenever you are writing the distribution factor for the uniformly distributed winding and you are writing the angle, because this is angle, this angle must be written in radians. It cannot be in degrees. It must be in radians. Is it clear? So if you put the values, what is the phase spread? The phase spread is mentioned as 60 degree of phase spread. So this is going to be 60 degree by 2 divided by 60 degree by 2, and because it is given in degrees, I have to change it in the radian. So this is going to be 180 degree and this is going to be pi. If you solve this, you will get the distribution factor. As per my reference, I can tell you, as per my reference, you must be getting it 0.955. You must be getting it 0.955. Please cross check this value. Everybody just tell me in the comment section, are you able to follow this? Everyone. Yes, everyone. Is it clear? Uniformly distributed winding, why we are using, what is the logic, what is the concept? Are you able to follow this? Now let us go to the next question. A synchronous generator with a synchronous reactance 1.2 per unit is connected to an infinite bus whose voltage is 1 per unit through an equivalent reactance of 0.3 per unit. So let us see the situation is something like this. This is your synchronous reactance, having some reactance, and this is connected through the infinite bus with some reactance. This is the situation. This is your infinite bus. This is your infinite bus. This is your synchronous generator. In the question, he is saying the synchronous reactance is 1.2 per unit. Suppose this is 1.2 per unit, and this reactance is mentioned as 0.3 per unit. Then he is saying what should be the value of EMF. This EMF belongs to the excitation EMF of the generator, excitation EMF of the synchronous generator, to give a maximum output of 1.2 per unit. Suppose this excitation EMF we are assuming as EF, and for the infinite bus, the terminal voltage is mentioned as 1 per unit. So this is going to be at 1 per unit. Now you know it's very simple because we are going to use the approximate power angle equation. Approximate power angle equation, and we can write the real power delivered by this generator. The real power delivered by this generator will be given as mod V1 mod V2, or you can write in terms of excitation EMF also, EF mod V X equivalent, and this is sine del. And this belongs to the maximum power which can be supplied by the generator to the infinite bus. This is the maximum amount of power which can be supplied by this generator to the infinite bus. So you can write this P max as mod EF mod V upon X equivalent. This P max is mentioned as 1.2. Excitation EMF magnitude you have to find. Terminal voltage of the infinite bus is given as 1. Now what is X equivalent? This X equivalent is the total series reactance between the generator terminal and the infinite bus. So this is 1.2 plus 0.3. This is 1.5 per unit. Let's put it 1.5. If you solve this, you must be getting excitation EMF magnitude as 1.8 per unit. Is it clear, everybody? Yes, everyone? Yes, Mr. Murali, you must be getting it 1.5, na? Multiply 1.2 and 1.5, it must be 1.8. You can use some supercomputers also, no problem. Now, before we go to the next question, so the workshop that I told you that how you are going to manage if you are a working professional or if you are already in your college studies, your GATE preparation. We have a workshop on 27th of September, 8 p.m. in the evening. You can join it, but for that you have to get yourself registered. Is it clear? Now let us see the next question. Now this is interesting question because this question can be categorized into synchronous machines also. This can be categorized into power system also for reactive power compensation. He is saying a 3-phase induction motor draws 1000 kVA at a power factor of 0.8 lag. A synchronous condenser is connected in parallel to draw an additional 750 kVA at 0.6 power factor lead. What is the power factor of the total load supplied by the mains? Very interesting. So the situation is something like this. This is the service mains, okay. Now this is going to be your induction motor. This is going to be your induction motor, and here you have connected a synchronous condenser. You have connected a synchronous condenser, okay. Now you must be knowing what is a synchronous condenser. Let me tell you. Because there may be some confusion in this question, that is why I want to remove this confusion. Generally people are ignoring this, but you must be knowing this. What is the difference between a synchronous condenser and a synchronous phase modifier. You must have studied it in the power system, reactive power compensation. When you talk about the synchronous condenser, it is overexcited synchronous motor at no load Baba. This synchronous phase modifier is again overexcited synchronous motor having at least some real load, at least some real load connected to shaft. Are you getting this difference? Perfect, Sudeep, perfect. Are you getting this? But if you see this question, in this question the data is given such that there is a confusion that he is talking about synchronous condenser, but the data he is mentioning that belongs to actually synchronous phase modifier. Okay. Okay. Anyways, so what is happening here? See, he's saying three-phase induction motor draws 100 kVA. So this is taking 100 kVA at which power factor? 0.8 lakh. 0.8 lakh. Now he's saying a synchronous condenser is connected in parallel to draw an additional 750 kVA at 0.6 power factor lead. Now he is taking 750 kVA, okay, at 0.6 power factor lead. Can I write the same situation that instead of absorbing or taking the 750 kVA at 0.6 lead, actually it is supplying this much lagging reactive power to the system? This is equivalent, yes or no? Taking the leading current or supplying the lagging current is the same thing. You just reverse the direction, one minus sign is required. So basically what is happening, this synchronous condenser is supplying reactive power, lagging reactive power here. What this induction motor is doing, this induction motor is having a requirement of lagging reactive power because it is an induction motor, it works on the induction principle, so definitely it has the requirement of reactive power. Now whatever is the reactive power coming here, real and reactive power coming from the mains or the other part of the system, that will define what is the operating power factor. So the first thing I must be confirming is what is the reactive power supplied by the synchronous condenser and what is the reactive power absorbed by the induction motor. So let me first write it. What is going to be the reactive power absorbed by the induction motor? It is going to be 1000 because it is kVA and it is going to be sine of what? Sine of the power factor angle. So this is going to be sine of cos inverse 0.8. Can you find this value, everybody? And what is going to be Q synchronous condenser? This is again going to be 750 kVA and this is again going to be sine of what? Cos inverse 0.6. Just try to solve these two values and you will get your answer. Everybody, are you getting this? Everybody just tell me. Yes, everyone. I don't have the reference value, that is why I'm asking. Just yes. See, this part you can easily simplify instead of writing this, okay, because you know if cos phi is 0.8, then what will be sin phi? It will be 0.6, yes or no? So simply you can write here 0.6 and it is going to be 600 kVAR, kilovolt ampere reactive. If you simplify this, this will also give you 600 kVAR. Now it is a very interesting situation that the reactive power requirement of the induction motor is exactly met by the reactive power supplied by the synchronous condenser. It means the reactive power supplied from the mains is going to be 0. If this is 0 and this is a power triangle, this is the real power coming from the mains, this is the reactive power coming from the mains, this is the complex power. You are saying that this Q is 0. This Q is 0 means what? This is also 0. When phi is 0, what is cos phi? Operating power factor of the mains. That is 1. That is unity power factor. Yes, Sudeep, approximately it is going to be 600 kVAR. So, A is going to be the correct option. A is going to be the correct option. Everybody is getting this? Say yes or no. Everybody is getting that. Let us see the next question. There is a 3-phase, 4-pole, 48 slots where the coil span is 1 to 9th slot. Now he is asking the pitch factor. Now what is pitch factor? Let me just show you once, then we can proceed for the question. Suppose first we talk about the full pitched coil. Full pitched coil. Suppose this is the north pole and this is the south pole. This is the north pole, this is the south pole. Suppose your winding is something like this. Suppose this is your winding. When we say it is a full pitched coil, it means what? We are defining the coil span by, suppose, gamma. Gamma is the coil span. Okay. When this coil span means top coil and bottom coil. This total gap, gamma, is equal to the pole pitch. You know what is a pole pitch? That is 180 degree electrical. That is 180 degree electrical. Such a coil we are calling as a full pitched coil. But in order to avoid some harmonics, in order to avoid some we don't want to AKG, Mr. AKG, we don't want to go into that formula. Just try to understand the physical interpretation. Now suppose we have a short pitched coil. Short pitched coil. Now in the short pitched coil, what we are doing, just see here. Again I am trying to remove the confusion. This is the north pole, this is suppose the south pole, and this is your coil. So what we are doing, under the north pole it is okay. Okay, but instead of going to the full pitch like the previous case, we are going little less. We are going little less. So we are getting a situation something like this. Now our coil span is going to be gamma. Yes or no? This is going to be gamma. And this angle by which the coil is short pitched, this we are calling as alpha. This we are calling as alpha. Alpha is the short pitch angle. Short pitched angle. And if you see, now the pole pitch is 180-degree electrical like this. So can I write alpha plus gamma is equal to 180-degree electrical? Yes or no? Yes, everybody. Can I write alpha plus gamma is equal to 180-degree electrical, where alpha is the short pitched angle and gamma is the coil span, top to bottom coil, top to bottom coil. Now, my friend, in the question he is saying the coil span is 1 to 9th slot. So he is giving you in terms of the slots. So let me just draw it to make it clear for you. I hope you enjoy my artistic capability. Suppose this is slot number 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9. Okay. So we are interested in 1 to 9th slot, he is saying. He is saying 1 to 9th slot. It means what? The top coil side or the conductor is placed here, and the bottom coil side or the conductor is placed here, and this is going to be my coil span. This is going to be my coil span. Can you tell me how many number of slots are involved here? Yes. 1, 2, 3, 4, 5, 6, 7, 8. In between the top coil and the bottom coil, there are 8 slots involved. So this gamma is going to be 8. And what is the angle subtended by one slot? This is beta. This is beta. What is beta? 180-degree electrical slots per pole. What are the number of slots? 48 slots. Number of poles? 4. Number of poles? 4. Just solve this and tell me what is the value of beta you are getting. You must be getting 15 degree. Yes or no? Everybody is getting 15 degree. Beta? Yes, perfect. If you are getting 15 degree as beta, what is going to be gamma? This is 120-degree electrical. But we have just seen that for a short pitched coil, we have just seen that alpha plus gamma is equal to 180-degree electrical. Already we are getting gamma is 120-degree electrical. So what is alpha? Alpha is 180 degree minus 120 degree, that is 60 degree. So what is the pitch factor? Pitch factor we are defining as cos alpha by 2. So this is cos 60 degree divided by 2. This is cos 30, that is root 3 by 2 or 0.866. So 0.866 is going to be the pitch factor. Yes, everyone, just tell me in the comment section, are you able to follow this? Mr. Murli, are you getting this? Why you are writing 3? This is 8, na? This is 8, na? See, 1 to 9 slots, there cannot be 9 slots. If you count from 1 to 9, how many numbers are there? Because 1 and 9. In between how many numbers, how many slots are there, you have to count. So 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9. So you will be getting 8. Are you getting this? So today we have taken little simple question, but don't worry, okay, because tomorrow, that is Monday 6 p.m, I will be coming up with some real advanced good quality problems. EKG is lot of derived formula. Formulas you have to remember, because if you want to achieve something which you have not achieved till now, then you have to do something which you have not done till now. Okay, so you have to have that much commitment, patience. Anyways, again I am saying, if you want to get a scholarship, so BYJU'S Exam Prep has a scholarship test which you can attend, which you can scale up your performance in the real examination. At the same time, you can get the scholarship also. So this is all from my side, friends. Thank you so much for joining me in the session. I hope you enjoyed and learned a lot. Let us meet in the next session tomorrow 6 p.m. in the evening. And I hope transformer is not completed, Murli. Transformer will be coming after this. Okay, after synchronous we'll be having transformers, and in the last we'll be having the DC machines. Okay. So friends, do not forget to join my personal Telegram channel, that is Electrical by Ashutosh Saxena. Why I am saying this? You can raise your number of doubts, but the most important part which will make these 45 minutes or 50 minutes, 1 hour worth. Just after the session, I will be posting the complete PPT of this session in that group. You can enjoy that PPT anytime. You can, if you are traveling, if you are sitting somewhere, you are in washroom, or you are with your girlfriend or boyfriend. So don't waste time. You can just flip through the pages and you can revise Synchronous Machines Part 1. Thank you so much, friends. Take care of yourself. Stay tuned and let us meet tomorrow 6 p.m. to have the second part for Synchronous Machines. Thank you so much. Take care. Thank you.